Welcome back. They give us a bit of an unusual assignment in this question where they say, how many different ways can you arrange this number of atoms, basically? Structural isomers are different things that you can make using the same pieces. So the example I usually use is like if I take some Lego bricks and I make a house out of them, and then you take apart my house and you use the exact same bricks to make a dog, my house and your dog are isomers. They're different shapes, but they're made using the exact same parts. With in chemistry, it means you take the same 6 carbon atoms and the same 14 hydrogen atoms, but you can put those together in different ways, as we've learned in the last several lessons. And though those things might have different names, they are isomers if they're made of the same chunks. So this is not something we've practiced a lot, but a suggestion I have to get this going is we've learned so far that organic compounds have a primary chain and then they can have branches. And if you have 6 carbons to work with, here's some ways you could arrange that. You could have 6 carbon atoms in your primary, which leaves you 0 to go in branches. That's the simplest thing you could do, is just have a 6 carbon stick. Or you could go with 5 carbons in your primary, and then that would leave you 1 carbon that you could put in a branch someplace. Or, colors are fun, I'll keep switching colors. You could do 4 carbons in the primary, which would leave you 2 carbons to put in branches. Or, you can see the pattern here. You could go with 3 carbons in your primary, which would leave you 3 to go in branches. Now, I'll keep going with this for a little longer, but you're going to see there's a bit of a problem here. You could put 2 carbons in your primary and 4 in branches. Or the last part of this progression would be just 1 carbon in the primary, and that would leave you 5 carbons to put in branches. Oops, branch starts with B. So if we just follow that progression where the primary goes 6, 5, 4, 3, 2, 1, and then all the remaining carbons are in branches, that's a starting point. It gives you something to think about. But if we reflect on this a little bit more, can you have a single carbon in a primary and then put 5 carbons worth of branches on it? That doesn't really work, does it? As soon as I put a carbon on this and call it a branch, it's like, well, didn't I just make my primary longer? So some of these are simply not going to work. This one in particular, I don't think will work. 2 in the primary, if I put a carbon anywhere on either of these to try to lengthen or to try to add branches, I'm effectively lengthening the primary, so I don't think that one is viable either. This might work. If we do 3 carbons in our primary, can I put 3 carbons worth of stuff on branches? I can go C, C. I was thinking of putting another one, but I can't have 3 branches coming off here because this carbon only has 4 arms, so that's a hard limit. I could do this. Do you see the problem with that one? What I'm trying to do here is have a propane as my primary, and then have a methyl group branch and an ethyl group branch. Why does that not work? You have until I change colors to find the answer. The problem is, if we put this on here, then someone who comes along is going to say, well, clearly your primary is this longest branch here. You can't say there's a 3 carbon primary. The primary is actually 4, and you've got branches coming off of those 2. So this doesn't hold up with 3 in the primary and 3 on branches either. So far we've had 3 of these flop, which is not a great record. But now these start to work. You can have a 4 carbon primary. 1, 2, 3, 4. And now, could we attach 2 carbons worth of branches to this? That sounds like something we could do. We could go 1, 2. That's all right. That would be 2,3-dimethylbutane. Could we put them both on the same carbon? I think that would work also. We could have 2,2-dimethylbutane. So there's 2 viable isomers. Could we do an ethyl group on this? If we do C, 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 C for our primary, what if we put an ethyl group on there? What do you think of that? This produces the same problem as these other ones that we were looking at. If you, as soon as you put this on here, the longest path through your molecule becomes this, and you haven't really made a, it's not a butyl, it's not a butane anymore. Now your primary is 5 units long, and so you don't have 4 in the primary and 2 in branches anymore. So I don't think we can make an ethyl group work with this. Also, if you were thinking of putting a carbon on either end, that doesn't work because that again makes it stop being a butane. You've just made your primary longer in that case. So I think we only have 2 viable options that are 4 and 2. We have 2,3-dimethylbutane and 2,2-dimethylbutane. If we go to a 5 primary, okay, for colors, 1, 2, 3, 4, 5. Now we have 1 carbon we can put in a branch. Where could we put it? We can't put it on here, or we've just made hexane. We could put it here, and that would be 2-methylpentane. Or we could put it here instead, and we'd have 3-methylpentane. Or could we put it here? Not so much. If we put it here, you might be thinking 4-methylpentane, but we should start counting from the right end now to keep our numbers lower. That just gives you 2-methylpentane again. So I think we get 2 more viable options from that. And I don't think there are any more possibilities with 5 and 1. And then we have the obvious boring thing. If you put all 6 in the primary, then you just have hexane, which is a stick. So 1 possibility here, 2 more here, 2 more here. That should be our total. And if you can find more, I'll be delighted, and you'll get some bonus points. So go ahead and kick it around a little bit if you want to. But if this made sense to you, the different ways that we can arrange these things, that's good. It's just, it shows that you're used to these pieces and all the different ways that you can configure them. Hope that makes sense. See you in the next one.